Good evening to all the participants, speakers, and organizer of this AICTE sponsored ATAL Faculty Development Program. It is my privilege to welcome you for this technical session 10, which focuses on highly specialized and transformative topic, uh, development of customized surgical osteotomy guide in ablative tumor surgery for accurate mandibular reconstruction with digitally designed maxillofacial prosthesis. The session addresses a critical domain in medical science where cutting-edge technologies such as 3D printing and digital design are being utilized to revolutionize surgical precision. Patient outcome in mandibular reconstruction. This topic is not only innovative but also immensely impactful in improving the quality of life for patients undergoing complex reconstructive surgeries. To enlighten us on this interactive and fascinating subject, we have the honor of welcoming Dr. Varun Khandelwal sir, a visionary expert in the field of maxillofacial surgery, prosthetic design, and digital healthcare innovation. Before starting the presentation, I would like to introduce our today's honored guest. Dr. Khandelwal has extensive expertise in surgical planning, custom prosthetics, and implementing advanced digital technologies in the healthcare. Sir is a founder and CEO of Hill Yantra Healthcare Innovations Private Limited. Sir has having an experience of 10 years in medical innovation, density, and research. He is renowned for his pioneer work in developing personalized surgical solutions for complex cases, particularly in head, necks, and reconstruction surgeries. His innovative approaches bridges the gap between medicines and technology, using customized surgical guides and digital prosthetic solution to enhance the surgical accuracy and patient care. There are so many awards and grants achieved by Dr. Khandelwal sir. He is getting a first prize in scientific paper presentation at International Digital Dental Congress held on 2024. Second prize in TI Global Entrepreneurship Competition at 2024. Nidhi Prayas grant from Department of Science and Technology, Government of India with an amount of 9 lakh for single operator syringe for ultrasound guided procedures. Sir has selected for NVIDIA Inception program for smart dental handpieces project funded by the Jodhpur City Knowledge and Innovation Founder. Sir has successfully organized Indian Conference on Meditech Innovation 2023 at Indian Institute of Technology Jodhpur and All India Institute of Medical Science Jodhpur. Sir has represented IIT Jodhpur at G20 Health Summit Hyderabad in August 2023. Sir is getting an award for technology readiness for endodontic treatment device in medical devices innovation courses at BTech IIT Bombay. Sir is winner of Medha 2022, which is held on BTech IIT Bombay. Sir has getting Marathwada Meditech Lab, Aurangabad offered the rapid prototyping services coupon, which is worth of rupees 20,000. Sir has getting Best Innovator Award in Bio Innovative Competition at National Bioengineering Conference 2022, NIT Rourkela. Dr. Khandelwal has also contributed significantly to research and education and having presented his finding in national international forum and mentoring young professionals in his rapidly evolving domain. Today's Dr. Khandelwal will take us through the fascinating process of creating customized osteotomy guide for mandibular reconstruction, showcasing how digital tool and advanced prosthetic design can transform surgical practices. Let us welcome Dr. Varun Khandelwal to share his expertise and insight on this groundbreaking topic. Sir, over to you.
hope my screen is visible to all.
Yeah. You just make it in the
Yeah,
presentation mode. Screen is visible, but it's not in the presentation mode. Your
yes,
other
sir. Yeah.
slides are also visible. Or you can choose the entire sharing of entire screen option. That would be better.
It's the entire screen only I shared. Just a second, like because of some sharing issue, it must be there. Yeah. Now you can see the slideshow.
Yeah.
Yeah.
Now okay.
Yeah. So good evening, everybody. So thank you for a very elaborative introduction, but that is not actually required. So the previous speaker set a good base for me to step on. So I just pivoted a little bit in my topic about the customized osteotomy guided in cases of tumor resective tumor surgery for mandibular reconstruction, because many of the previous author have spoke a lot of about this technique, and I'll be like in interest of the forum and maybe in the advanced additive manufacturing technique and also the AI component which is associated in the future perspective of this technique. I would like to speak about the digitally designed maxillofacial processes, which is a kind of untouched branch, and also which is spoke very little about nowadays. But there is a huge problem associated with the maxillofacial processes, which are highly demanded, and especially after the COVID-19 infection. So my slides are not moving. Sir, can you share on behalf of me? I have shared you the presentation. I don't know, like there is some issue. Yeah,
Yeah, yeah.
now fine. Yeah. Now the slide are changed. So, I joined this program like IIT and AIMS Jodhpur medical technology program in 2021. And as Nakul said, like in the previous presentation, like there is a need for this collaborative research. Now the government is also doing necessary step for such collaboration. And I am fortunate enough to be a part of such a collaborative program between the IIT and AIMS Jodhpur. And after joining the program, I completed my master's, and then I was fortunate enough to get through the Stanford Biodesign process, India, where we learned about like how a medical device or a technology is developed in conjunction with a technical institute, like the engineers with us. So that was a good learning in this 3 periods of time, and then we designed a good process for such maxillofacial processes. Now, before I joined the program, like many patients used to ask me about like, can they order a replacement body, please? Because this is constantly malfunctioning. So what do you think? Like, is it really possible? But the answer is no. But there are some kind of a patients like who are actually requiring the replacement of their body plus because they are missing in them. So such are the maxillofacial processes, or maybe any body part which are missing because of the maybe the congenital malformation, or maybe a disease, or after a resective cancer surgery, or after a cancer. And there is a special need if this part belongs to a facial structure, because it needs to be highly aesthetic. And if suppose a patient is having a missing orbit like eye or nose or ear or any complex facial part, they cannot go social, they cannot represent themselves in the society, in the function, and they cannot perform their routine a daily task. Now, what happens? Like it affects their quality of life, thereby deteriorating their moral, and also there is a high sense of depression among them. So all over, like the main quality of life in such patient are very much decreased or maybe compensated. Maybe we can say, and also there is a second problem, like there is very few good prosthetic center like the maxillofacial prosthetic center which are available in India or in country, and also it requires a lot much time to fabricate such kind of a processes. Now these defects are compensated by the pigmented silicone material. This silicone material is not a very stable material. It deteriorates with respect to time and temperature. Also, because of moisture, there is changes in the dimension of the material, which requires replacement of the processes. Now, every time the patient has to go through a same kind of a pain, longer pain, higher expenses, and then also the output of the processes is not very much good. Also, every time the patient will be having a new kind of a processes which will be differ in with respect to shape and also fitting of the part. So they require again time to get adjusted with the newer processes. So these are like many problems which are associated with the existing maxillofacial processes technique, the way of fabrication, and also the behavior modification with respect to the patients. Now, there are like many such patients who are suffering from such maxillofacial processes. Like in the recent COVID-19 infection, like most of the patients have lost their eyes or maybe the maxilla, and they are complex in nature, like the maxilla with eye or with nose. So the multiple facial structures were also involved, and the figure was as more than 3,000 patients, like just in the COVID-19 infection. Also, like per year, more than 10,000 patients are losing their facial structure because of trauma. Maybe they are work associated or maybe the accidental trauma, and more than a lakh lost their facial structure because of the cancer or the resective cancer surgery. So this number is also very high, especially in India, where the oral cancer is very much prevalent. So another fact about these figures are that since these patients require like continuous rehabilitation, the numbers goes on adding. For example, like suppose today in this 2024 there are 1,000 patients. So this 1,000 patients will be requiring another new processes in another 2 to 3 years. So this number will go on adding to this existing pool of newer patients. So in a way, there is an altogether increase in this number. So this is causing a huge burning need among the healthcare providers to look into this domain. Now, as per our research and also like many of the patient conversation and the way which we fabricated the processes, we identify the three main pillar which are important for the maxillofacial processes. First is the aesthetics, second is the function, and third is the retention. So unlike the other processes like the hand or limb, like the foot or maybe the hand processes, most of the processes are covered with a cloth. So they come with a kind of a the mold where the shape and size can be constant to every patient, or maybe some kind of a mold are there with respect to male or female and small, medium, large kind of a thing. But this is not true with the facial part. Every part needs to be uh, custom made, highly precise, highly aesthetic, because it is going to be like seen by everybody like in the society. So it needs to be highly aesthetic. So the main requirement is the aesthetics. So it should match the surrounding structures. Also, it should be retentive in place. So it should not come out like while talking or maybe while walking or driving their vehicles, or also like performing their daily task. So this is also very much required. And third is it should perform a specific function, like it should uh, like close the nasal space, or maybe do not allow the foreign material to go inside the body. So the specific function it should provide. So a good processes should meet all the three the triad to be considered as a good processes. So this is a like very demanding field with respect to a accuracy and also uh, the functionality with when we compare with the other processes of limb and etc. So this is conventional workflow which is there with the existing way of practicing the maxillofacial processes. First is the like when the patient comes to the practitioner, the impression of the area is made. So this is a case of orbital processes, and then a master die is fabricated. On that master die, the operator carves into a wax the proper processes as per his expertise. Now, this step requires a lot of like technical expertise, and also it demands a lot of time with respect to the practice. So this is mainly lacking with many of the practitioners nowadays, and they cannot give more time, and also they are not like everybody is not very technical or maybe the artistic to do a precise carving which represents the exactly the antagonist facial structures. Then the trial of process is done. Now this is a kind of a iterative step. So many times the wax up and the patient trial, this cycle goes on, and after that the flasking and packing into a silicone is done, and the final process is delivered to the patient. So this you can see like it involves a lot of steps which are time consuming. Also extensive skills are required, and this is the main reason because of which these are not routinely practiced by the practitioners, and also this is the reason why the patient are suffering for not having a good maxillofacial processes. So these are the problem which I highlighted, like the high requirement of the skills are there. Also the fabrication time is very high, and there are multiple steps which are involved in the workflow of the fabrication of the processes. And also like because of the multiple workflow, the outcome is not very accurate. So sometimes the fitting is not there and it may not perform the specific function, and a kind of adjusted processes are required. And many of them like the geriatric patient where they have a like compromised kind of a lifestyle, they even not prefer to wear processes if it is not well fitted. So these are the really very big problem for such patients. So we have come up with a like digital workflow for such processes and reduce the like steps in the workflow, where we are now doing the digital scan of the defect of the patient. Then a CAD model is made of the defect, where using a 3D sculpting tool, like yesterday also like the PU server telling about this mesh mixer. So this is also one of the good software where we can sculpt this defect for the processes. Then a mold is fabricated using a 3D printing process, simple 3D printing process. Now this mold is like this can be of simple PLA material or maybe a acetate also. So, but a simple layering is required for to prevent the reaction between the silicone and also the mold material. So here, kind of a challenge is there with differs with as compared to the routine 3D printing technique. And then in this 3D printed mold, the silicone is packed and then the final process is delivered. So the total steps in the workflow is reduced, and also a predictable processes can be delivered to the patient. Now, I would like to present a case report which we used, completed the patient using this like digital technique. So this is a case of 32-year-old female presented to our department at AIMS. So she lost her left eye because of retinoblastoma at the age of 14 years. And then since 14 years, she is like struggling and finding some good prosthetic center, but she was very unsatisfied with his current and also the previous processes which she received. Like she traveled to Mumbai, also to Hyderabad, stayed there like for more than a month also. But after such investment of time and money also, like she was not very satisfied with the kind of a processes which was delivered to her. Then by profession, she is a teacher. So you
Yes,
can
sir.
imagine. Yeah, hello.
हो बोला ना.
Yeah.
एक मिनिट.
So you can imagine like the looks for him for her is very much important. Like because like daily she is going in front of like small children where afraid by such facial appearance, and it is imparting his the confidence. And now she was in a like state of depression, and in this state she presented to our department, like we think like we should provide a good process, and we employed this technique. So where we did this scanning of the defect. So this is a video, like in the upper right corner you can see the facial defect is scanned, and the optical 3D scan of the facial defect is generated. Then for the retention part, we like pointed out the strategic undercuts inside this defect, and then tried to like accommodate that defect using a 3D printed acrylic ring. So first was the step where we eliminated the requirement of the implant, which are routinely used for retention of such processes. Now, why implants cannot be done in every cases? Because many of the time, like since it is of resective cancer surgery, so after resection there are like chances of radiotherapy. So in that region, any kind of a surgery is anyways is a failure because of the compromised blood supply. So kind of a mechanical retentive feature can be integrated. So we try to strategically involve the undercut into the defect using a 3D printed acrylic ring, which is integrated into the processes, like further integrated into the processes. So this was done in a Meshmeasure software. So this is a 3D printed acrylic ring. Now the orbital shell was designed, and the uh, complete defect was sculpted in this software, and using some Boolean operations and some of the sculpting tools, we designed a trial analysis, and then with the image grid analysis, we try to position the orbital shell like accurately with respect to the this is the final outcome of the process, is like where after fabricating the the main processes, we did the external staining for the better aesthetic appearance. We implanted the some of the like hairs, like the eyebrows part with like again pin technique is there for integrating this hairs, like single hair into the orbit, and then try to match with the surrounding tissue. And uh, like no wonder like it is matching with the adjacent tissues, and also the shape was very good. But the main reason for success was the retention of the processes. Now every time, like when she is sneezing, or maybe driving the vehicle, or maybe talking to the person, so the process is not getting out of the space. Previously, she used to retain the processes using its spectacles, like the glasses which she wear. Now, without the glasses, also the process is retained into the place, and she can perform her routine procedure, like duties very comfortably. So this was the feedback like from the patient. And we were also very happy, like we provided, and then we tried to address the problem of a patient. But there was again like many problems which were associated to address in such patients. So like in this overall process, we were able to cut down the total treatment time to half of the total treatment time as compared to the conventional workflow. Apart from that, also the cost is now saved. Like if the conventional workflow, because of time, also you can estimate like around 30 to 50,000 is the amount of expenditure which is average for a patient like in the country. But through the digital workflow, we can again reduce it to around 50 to 20,000 rupees. But the another advantage is that now we are having a digital file of the patient, and we can save that digital file. Then every time in the future, like after 3 or 2 to 3 years, we can provide the same quality of processes to the patient. So this is the main value which we can add to the life of the processes. So our main aim is that like we can have a centralized lab where we can get a digital scan across the country or maybe globally, and then we can process a trial, and then after trial we can deliver the same quality of processes every time to the patient. So there is no need the patient coming to a center which is situated far away from their country, like far away from their residence, and also like they can simply go to a dentist or maybe a practitioner who is having a scanner. Then the scanned area can be sent to a centralized lab, processed, and then the final process can be delivered to the patient. So this is the value which we want to give to such patients. Now, moving a step ahead, what we did, like there was a main problem like which we identified was about the skin matching, like the shade selection, because that took maybe the major time in developing the process, like in matching the shade of the processes. Like it was a trial and error method. Like every time we used to mix different quantities of pigments and then match it with the patient surrounding tissues. But every time after the process was fabricated, it was having a different color. And instead, like we did external staining, the shade was not matching. So this is a bigger problem with respect to such processes. So what we did a deep learning algorithm for shade matching and developed a scanner like this digital scanner, where we can now scan. Like this is a live camera feed where the red box is the area where we want to match the shade of the processes. So that area is selected. After we capture this image, the software will tell us about the exact amount of recipe of the various pigment which needs to be added to the pre-quantified amount of the silicone. Like with respect to the 100 gram of silicone, you can see like the software is now able to tell like what is the amount of which pigment which needs to be mixed with 100 gram of silicone to get this shade. So this is how like the technology can simplify the process and also like give a better or maybe the improved patient outcome with respect to such time consuming and also the tedious step, because of which the practitioner is also not liking this procedure to do very routinely. So now this is very simple step where you can know the exact recipe of the various pigment which needs to be mixed with the silicone, and then you can just blindly mix this quantity and then continue with the procedure, and you will get the exact amount of shade. Again, like this is needs to be further validated with wider population. This is like we done with for the Indian population only. So our next step is to move towards a direct digital processes. So what we talked previously was about the indirect digital processes where we are using the mold to fabricate the processes. So our main aim is to why we cannot directly print the silicone, so that the mold is not required. So further we can reduce the total treatment time of the patient and improve the accuracy of the procedure. So this is the main thought, but there are like many obstacles or maybe the limitations in the currently additive manufacturing technique, also the material advancement. So but if this is done, so this can be proven like highly accurate, and also the high aesthetic results can be given. Now, one problem with this indirect, like two problems are there, like with the indirect technique. First is the like you cannot add to the different consistencies of the material. Like if you touch your ear, so somewhere it is hard, somewhere it is soft. So, but if you are fabricating it using a mold, so you will have a same consistency throughout the processes. So it will reduce the lifelike feel of the processes uh, if it is indirectly processed. But if I am directly 3D printing the processes, so I can just manipulate with or play with the different molecular weights of the silicon material, and then print with a different consistency having in the same processes. Another now our shade is like scheme differs in the pigmentation with respect to area, like somewhere it is dark, somewhere it is fair. So that gradient also we can match during the digital during the direct 3D printing of such processes. So this is like our future work, like which we are doing in this domain. So this 3D printing is like in between the metal 3D printing and the 3D bioprinting. So it shares the feature of both the 3D printing part. Like the metal 3D printing has like the problem like how the powder is solving the support structure, giving support structure for the 3D printed the metallic part. Also the bioprinting in how the scaffold are prepared, and also the structure are supporting to the main surfaces in the bioprinting. So I continue. Hello.
Yes, sir. Please continue.
So there is a like sharing between these two parts. So this silicon 3D printing is between these two. It shares the feature of these two printing or the additive manufacturing processes. So some of the shortcomings with the direct 3D printing silicon additive manufacturing process, like there is a lack of established additive manufacturing technique and handling of such viscous thermoset material. Like uh, silicone as a material is a non-Newtonian viscous fluid, so it like behaves differently under pressure. So this is the main challenges while working with the silicone for 3D printing kind of technique. And also the commercially available silicone which are there in the market are not very compatible with the existing additive manufacturing technique. So this shortcoming needs to be addressed before like directly 3D printing the silicone material. So now there is a Gartner hype cycle where this talks about how the technology and the application mature and are adopted with respect to time. So first of all, if any technology is introduced, there is a technology trigger where they are applied in various domains, and there is a huge peak, like same like as that of the 3D printing technology. Now everybody is doing so. The application, the area of application is very large. Then there is a peak of inflation where our expectation is not made. Like some of where it will fail, or somewhat it will not perform to the optimal level. So there is a peak, and after that there is a downfall with a trough of disillusionment, like where our illusion, like our eyes are open, like what exactly the technology will behave and where exactly it should be applied. So it will again have a slope of alignment where it will increase, and then it will have a plateau where like the exact application we will know, and it can be used for the production and to solve a exactly. Now the silicon 3D printing is somewhere here at very nascent state, and it requires a lot of time to get into a mature phase and a stage of productivity, or maybe the plateau of productivity to reach. So many of them are trying newer methods like to 3D print the silicone. So there are like many techniques which have been established and also they tried, and some of them are very promising, some of them are having some of the limitations or the drawbacks. So these are the four areas where the direct 3D printing needs to be addressed, like the metallurgical advancement, additive manufacturing technique, the advanced CAD designing, and the AI algorithm. Yeah, can you see my screen again? Hello.
Yes, sir. Your screen is now visible.
Now visible, right?
Yes.
Yeah. So these four critical areas we are now working upon, and one by one I will just briefly talk about like what all things we are doing in this four areas. Like this is the general like classification of the silicone which are available commercially. So there are two major types of the silicone, like heat temperature vulcanized or the room temperature vulcanized silicone. Now for the maximization processes, mainly used materials are the room temperature vulcanized silicone, and this room temperature vulcanized silicone comes into two uh, types, like the one component. So the one component is the setting reaction is caused by the moisture when it is exposed to the external environment. And the two component system, it comes in the two parts. First is the base part, and second is the catalyst of the cross-linker part. So here the initiator can be a photo initiator like the UV light, or maybe a platinum or a catalyst which can be activated upon mixing the two components. So these are the main background of the silicon which are available commercially. So this two component system where it comes into the base and the catalyst part are the major highlight with respect to the direct 3D printing silicon. So this is a one of the 3D printing technique where a free form reversible embedding technique is used. So here this bed is with a viscous silicone material where the syringe is like extruding a cross linker into that, and again this material itself is supporting the main structure for during the 3D printing. So this is a kind of a free form reversible where a well of viscous material, which is a base in this case, like the base which is a poly dimethyl siloxane, and then the cross linker is extruded with the this extruder head, and the 3D printing is done. Now there are like some of the disadvantages, like the two kind of a material cannot be used with this 3D printing technology, and also there is a lot of wastage of the material inside this well, and also the post processing is very tedious. Like when we get out, like take out this printed material, many times it get distorted because of not adequately cured, because post processing required again UV light curing, which cannot be done inside this well. So these are some of the challenges with this free form reversible embedding. So what we suggested, and we are also developing this dual pneumatic. So we are developing this dual pneumatic piezoelectric extruder. So in this first image, you can see like this is open, like this space is filled with a this silicone material, which is pneumatically controlled. So this the flow of this material is pneumatically controlled, and this is a piezoelectric crystal. Now when the 90-volt current is applied, so because of like change in the dimension of this crystal, this space gets closed, and then it extrudes a picoliter of silicone material into the build platform. Now this uh, head X and Y Z direction, the build platform moves in the Z direction. This way, the structures can be printed. Now, in this head, there are two inlets. One is for the cross linker and another for the pigments. So the cross linker is like uh, screen is again visible. Hello.
Yes, sir.
Yeah. So uh, there are like two inlets which are attached. One is for the cross linker and another is for the pigment. So this cross linker is as the different molecular weight silicone, where the different consistencies of the silicone can be achieved in the same processes, and also the different pigment. Not visible to all. Hello.
Sir, it is just loading. The slide are not visible.
Okay. Now.
No, sir. Just a loading icon is there, but a slide are not shown.
I will wait, like maybe because of network issue, it is having some time, taking some time.
Okay.
Yeah, now it is visible. Yes, thank you, thank you. So, I think I was explaining this two inlets for the cross-linker and the pigment. So, from this cross-linker, the different molecular weight silicone material can be created in the same processes, and also the variation of the shade can be achieved by the pigments. So please stop me if the screen is not visible.
Sir, your slides are visible.
Yeah, okay.
Please
And
continue.
then, yeah, and then like when the voltage is applied, this nozzle get closed and it extrudes the amount of silicone which is collected into this well with the cross-linker and the pigment. So this is a kind of a technology which we are developing at IIT Jodhpur. So this is the input data, how the technology will behave. So after the CAD file is transferred to a slicer software, and then the G coding is done. So this green is the unpolymerized viscous material which supports the pink material, which is a polymerized silicone. So lastly, like after the whole structure is printed, this unpolymerized is washed using a like simple water, and then the post curing is done either subjected to temperature or maybe the light activated, depending upon the material which is used. So further, like coming, like we have developed a AI algorithm for this shade matching, as I talked before also, but now we are developing a AI algorithm for generative technology, where we can generate the defect like after getting the 3D scan of the defect. So what we are doing, like initially the shade and the different dye combination is done using this digital scanner or the shade matching tool to give a personalized shade appearance, and then using the advanced GAN network, like the generative adversarial network. So we are generating the facial defect. Uh, Now the technician need not to like sculpt the defect using the different tools. The AI will do that, like depending upon the antagonist side and also some of the principle of the facial anatomy. So based on that, the 3D structure will be generated automatically, like within minutes. So in a way, like we will be saving a drastically like the time with respect to 3D sculpting the defect, where the technology will itself generate the defect, keeping in mind the strategic undercut and also the facial forms, where like 2 or 3 different designs can be given to the patient, and the best suited design can be selected, and then the final processes can be delivered every time to the patient. So this is what like AI can again revolutionize this field of maxillofacial processes, where just having a 3D scan and then a generative AI can just build the defect, and then we can directly 3D print the processes and then deliver to the patient. So this technique will not only save the time but also the cost and also the future appointment. And also this technique can be applied to the other areas, like the entertainment, where the facial makeovers are done, like in the Bollywood, Hollywood, and other entertainment industries. So there is a huge scope of such technology where uh, engineers and the doctors can collaborate and do wonders with this. So this is a like deep convoluted GAN network to reconstruct the facial region. So now we are testing with the 2D images where like in the middle image you can see the masked image, and then the third one is the the generated image with the GAN network. So this is a 2D, and after that we are now doing with the 3D facial structures also. So the results are good, but like more research is required in this domain, and yes, like lot of training with respect to the AI model needs to be done. So we have totally completed like what we started initially, like with the conventional workflow where the doctor is actually taking the impressions of the part and then manually carving out the part and then delivering the processes to a totally digital workflow where we have converted this pixels to processes. Like now the 3D image, each pixels our software is analyzing and then converting it to a clinically usable data with respect to facial form and then shade and also the retention of the processes. So these are the like main steps in our algorithm, and then finally a 3D printed process is delivered to the patient. So this is future processes which I talked about, and this is my team. Here, like as we said, like we work engineer and doctor. Like I am a doctor, and then these three are my team members, like who are engineers. So Sai is the main technological expert, like who is doing the machine learning and also handling the optics part of the project. And Manik is the main AI expert. Like his background is the computer science engineer, and Divesh is the main operational head of our system. So this is like our ecosystem partner. So we are the pioneers of this medtech ecosystem at AIMS and IIT Jodhpur. And this is a part of Principal Scientific Advisor, which is a Government of India initiative. And also, like we were able to take part, being as a fellow of Stanford Biodesign, where we learned this bioprocess, identifying the problem and then validating the problem to a large audience, and then talking about the various solutions. So we actually brainstorm with multiple solutions which can be provided to a patient and also to the operator, what actually the operator is wanting with respect to the comfort and also the usability and also the cost which is associated, because India is majorly a very cost sensitive market. So during our fellowship, like we actually go into the field and then talk to the various stakeholders related to this maxillofacial process, and then try to design a technology which is best suited for the society. So in a way, like we should not go over featured or under featured with our technology. So we should able to provide the exact the amount of technology which is required and which can be translated or maybe the used by the society. Now, like we are like in connection with the Indian Dental Association also, like which is a very largest dental association in India. Like last month only, like we had meeting with the national body, like Dr. Ashok Doble, who is the president of National Body ID. So they invited us for a global oral health conclave, which is going to be held in the month of May 2025. So like the ecosystem is very supportive, and then there is a huge chances to grow. Like if you correctly identify the need and then address and go in the same direction. And also like some of the industry partner like the NVIDIA, so they are we are a part of their inception program, and also they are helping us for with their deep learning institute, to train the model. Also we got the cloud support where we can use their GPUs and then train our models. And also we get supported by the government of India through various grants. And also this idea was represented at this Inventive Summit, which is the largest R&D fair which held at the IIT Hyderabad last year. So the main point is that like many of them are looking for such advancement which can actually solve the need of the society and then addresses the actual problem. So this was me. Thank you. So I will open the forum for further discussion.
Thank you so much, Dr. Varun Khandelwal, sir, for such an enlightening and thought-provoking session. Your detailed explanation of the customized surgical osteotomy guides and their application in mandibular reconstruction has opened up new horizon for many of us here today. Your insight into the integration of digital design and prosthetic have truly showcased the transformative potential of modern medical technologies. Now we invite questions from the audience. If any participant have any query or thought regarding the today's session, please feel free to ask, or you can either raise your hand or type your question into the chat box.
Yeah. So one question I can see is what is the difference between prosthesis and implant? So prosthesis is the structure which replaces the body part. So it doesn't mean like it should go inside the body, but implants will go inside the body. So maybe into a bone or uh, mainly into the bone, like implant goes. Also, there are some soft tissue implant which go into the muscle part or maybe the like sub dermal parts. So implants are the material which are implanted, which goes into the body, while the processes are only the replacement of the body part. So processes can be integrated or cannot be integrated, but implants are always integrated. Now there is one important like concept with respect to this processes and implant, which I want to highlight is that about the osteo integration and the osteo perception. So what is osteo integration? Like suppose I lost like my thumb because of accident, and then I am wearing a simple cap kind of a prosthesis, like simple cap kind of prosthesis. Now I cannot have the perception of tip of my thumb, like to hold the object. Like if I am holding an object, like I cannot have perception of the tip. I will hold it, try to hold it from the content. So this is like maybe the regression after the loss of my body part. But if I will have an implant into this bone, and after a successful osteo integration, then if I place processes over this, now with the period of time, I will able to have a perception of this tip. So this is called as the osteo perception, which is a like very good advantage of the implant over the process, like process over the implant. So now I can, by the period of time, I can learn like where the tip of my thumb is there, and then I can able to like accurately hold the object, which is the main benefit of the osteo because of the osteo perception. So these two things goes hand in hand, like implants and processes. So implants are done, and above which the processes are done. But as in case of maxillofacial processes, many times the implants are not advisable because of the irradiated areas, like because of after the cancer therapy, and also the patient is now having many pain. So another surgery is they are not very much comfortable with one more surgery of getting implant placed. So these are some of the problem with respect to the maxillofacial processes. Uh, Kumar sir is asking like which mechanical test and characterization is to be done before fixing new implant. Uh, New implant actually we cannot place any implant before regulatory clearance, and if we talk about the mechanical testing, simple the stress strain analysis needs to be done, like under both the static as well as the cyclic nature of forces. Like since if we talk about the dental implant, so in how much cycle of forces it will be having a fracture line, so that needs to be evaluated. But that is actually done if we are practicing any kind of an implant. Like if any company is selling the implant and which is now ready to get into the body, so this is already being tested for that. But this like both the static as well as the dynamic forces for stress strain analysis needs to be done for every kind of implant. I think like there can be two chances, like cases. First, like the topic was not understood, or otherwise it was very simple because nobody is having questions. Customized implant design. So customized implant design are like nowadays very routinely done. But again, like because of the expensive additive manufacturing technique, like with respect to titanium oxide, and like not only this manufacturing technique, but the manufacturing technique under controlled environment, like highly sterile environments is difficult. So having a clean room facility is not very easy, like to uh, maybe run. So there are very few clean room facilities which are available in India where such customized implant can be printed and then packed and delivered to the site of operation. Yes, maxilla with metallic implant, yes, it is possible. And it is done also like using a mesh of titanium. So they are replacing the maxilla, also the mandible. It is similar to the other joint implants which we routinely see, like the knee joint or the hip joint. So it is almost similar. Also, the TMJ joint, like this temporomandibular joint, is now replaced using a metallic implant. So these metallic implants are mainly the titanium alloy which are available. So some of them are surface treated, some of them are like highly porous. So depend upon the area of use, they are now fabricated. Also, like many of the now newer implants are coming in the like the root form implant, like where they are fabricating the implant as per the root anatomy, so that you can just extract the tooth and then place the newer implant exactly fitting to the site of the extracted teeth. So these are some of the like areas where the advancement is going on, but it needs to be like explored a lot.
How to
How
correct
to do?
it in errors during the digital conversion from DICOM 5 into 3D model?
See, like yesterday also, like Piyush sir was telling, like if we are using a FDA approved or maybe a good software, so anyways, this will be not a problem. And if we talk about this maxillofacial processes, so we have only used the surface scan, which in turn is like highly accurate data. But this conversion, if we are doing with a good software, so the errors are very minimum. And if you want to check, so there are some points like you can just have a two bony points and then uh, examine it with on a 2D radiograph, and then same distance you can verify with the converted DICOM file. That is one of the like method where how, from which we can cross verify the digital conversion of the DICOM. But now actually many of the softwares like I am using three shape software for surgical guide preparation. So they excuse me. So they supports the DICOM file. So the DICOM file need not to be converted into the 3D model. Like DICOM is itself a radiographic 3D reconstruction of the radiographic image. So they directly support the DICOM format. So the STL format is not required like in the newer software. Like the CT scan can be directly imported to the software, and then the surface scan can be merged with this DICOM file. Like yesterday, the Piyush sir was telling about like how he integrated the mandible into the face of that patient. Now, like we can just mark some points, like suppose the angle of mouth with the teeth. So the software will automatically calibrate both the data, the DICOM data and the surface data, and then merge the two format, the surface scan and also the DICOM format.
So I think the questions are over, and this session was really informative. As far as means tomorrow is the last day, and the sessions which this was the 9th session, and definitely it's a kind of a perfect combination from the engineers and the doctor. And today's session is also very much informative that whenever somebody lost his eye or lost some kind of even the nose, so how we can make it by biomedical application that replace the same thing, which so that because obviously it would be a very big complex whenever some somebody lost some kind of organ, and definitely it would be always a kind of a problematic whenever he wander in the society. So definitely the study which focused by Dr. Varun Khandelwal sir is a good solution, you know, for those patients or the case studies. Sometimes even no doubt the cost also matters, but I don't think spending rupees 1 lakh or 2 lakhs is kind of a thing of big money for such solutions. So, thank you, Dr. Varun sir, and hope we will have the same kind of a bonding in future also.
Sure, sir. Yeah.
So, yeah. Over to Nilesh. Dr. Nilesh, kindly go for the proceed for the talk. Thanks.
Definitely, sir. This interactive discussion has added a tremendous value to the session, leaving us all with a deeper understanding of the topic. On the behalf of the organizing committee, I extend our heartfelt gratitude to Dr. Varun Khandelwal sir for his remarkable contribution to this faculty development program and for sharing his expertise with us. Thank you very much, sir.
Thank you, sir.
Thank you. Thank you so much.
Yeah. And dear participants, actually tomorrow's sessions are not from 6 p.m. It will be from 2 p.m. Okay, kindly note, it will be from 2 p.m. and there will be the validatory function at 7:30, na, Dr.
Yes, sir.
Nilesh?
Yes, sir. 7:30 p.m.
7:30 p.m. So because tomorrow there will be 3 sessions. Okay, so we'll start from 2 p.m. Okay.
One more instruction I want to give. There is an assignment tomorrow at before 7:30, 30 marks question and feedback from all the participants. So please be ready. We will be sending the link into the chat box as well as a mail to all the participants.
Yeah, test.
Yes, sir.
Okay.
We hope that this session has inspired to all the participants to explore the exciting opportunity at the interaction of medicine, technology, and innovation. Thank you everyone for your active participation. Stay tuned for the tomorrow's session as we continue this journey of learning and discovery. Have a wonderful day. Thank you.
Thank you. Okay.